class 9 students, welcome to Diksha Vedantu, where we teach you not just for marks but for excellence. And today I'm your Aditi ma'am, and I have gotten you one of the most important chapters of your class 9th chemistry, atomic foundations of matter. Now students find it a little bit difficult to comprehend with this chapter. We started with which chapter was the first chapter? Exploring mixtures and their separation. Then we moved to journey inside the atom, and finally here we are, atomic foundations of matter, a little bit bigger step from our previous chapters. Correct? Now beta, in these chapters it is very important, the one thing you need to understand, that these chapters is somehow related to journey inside the atom but a little bit more complicated. We studied about how atom came into effect, right? What are all the theories that actually gave us the final structure of atom? Although it is still progressing, the new structures of atom we are still discussing, but till 9th class, this is the syllabus we have. Now, in this chapter, we'll study a little bit more about atom, how these atoms form the elements, and how these elements then combine together to form molecules. Now, molecules like what? Molecules like our acid, HCl, H2SO4, like our water, H2O. We all read that, right? So, how did they came into effect? What are the forces? Now, in H2O, hydrogen is there, oxygen is there, right? What is holding them together? How is hydrogen and oxygen form together? How do they sit together? That's the one thing we have to study in this particular chapter. Okay. So beta, the very first thing in this chapter you need will be a pen and a paper to make rough notes for this particular session. Okay, you write down whatever extra information I speak, and you will get the PDF in the description after this video as well. Okay, now let's start with our very first, that is beta, how does actually the first thing came this? See, in this particular chapter, atomic foundations of matter, first you understand what is matter. Okay, matter, basically something that has mass, that occupies space, is called matter. We studied about that, right? Solid, liquid, gas, all those things are matter. Now one thing we need to study in this chapter is the change. What is that change? Ma'am, when I have a glass of water and I add salt in it, we studied in exploring mixtures and their separations, right? Now, what happens? Why it tastes different? Because of salt. Okay, but does their mass changes? How does matter is affecting? So basically the first topic is mass change in a physical change. Physical change means I took two different kind of things and just added them together, or I took two things and separated them together, but physically, not chemically. Chemically means I'm not adding some chemical, I am not adding some gas, I am not heating it, I'm just simply adding these two things. So we have a very important activity in your NCERT, and we know activities are very important. Okay, so make sure you pay attention to this topic. So what is the one thing? Weigh your water. What we did, we took a weighing scale. Okay, this is your weighing scale. You took a glass of water and placed it on the weighing scale, and the water has a certain mass. Then you added some salt in it, and you will see the mass will increase, right? And you dissolve it. Now will the mass change? Now when the salt is dissolved, let's say you have water and you dissolved your salt in it, and the mass is this 55 gram. Now you swirl it, right? You swirl it. So will the mass change? Now that salt is dissolved in water, will the mass change? No, right? It will stay 55 only. It will stay 55. The mass has not changed, right? What does that tells us? It tells us that the mass of water plus the mass of salt equals to the mass of their solution. Salt plus water, salt solution, right? So that's the beauty about chemistry, that when two things are added physically, their combining mass is equal to the mass of the product or the solution that is formed. Correct? Done. Next beta, what is the one thing we take care of out of it? That mass of the solution, our water plus salt, is equals to the mass of water plus mass of salt. Let's say you have taken 10 gram of 10 or 100 gram of water plus 10 gram of salt. So adding them, what will we get? 110 gram. And what will be the mass of this solution? It will also be beta 110 10 grams, then simply we are saying in this particular thing, it's common sense. It looks like common sense right now, but in the next thing, in chemical change, you will see why we needed to study this before going on to chemistry, why we needed to study some common sense. Okay, beta. So same thing for tearing paper into two pieces, mass before, mass after. So you took a paper, you plugged it in half, and now also if you weigh those two separate things, you'll see the mass of those two papers is equal to the mass of the one single paper that was before they are tearing apart. Okay, thing, right? Then beta, we have conclusion that mass stays constant in all physical changes. Whenever any physical change happens, you add salt in the water, you add sugar in the water, you do anything. Whenever those things happen, we say that the mass before their change, the mass before adding these two things together, and the mass after adding these two things together, that remains the same. If you weigh sugar plus water, and it comes out to be collectively 55 gram, and a solution of sugar and water, it also comes out to be 55 gram. Understood? Clear? Why I am repeating all these things again and again? Because these are very common sense, and common sense is not so common actually. So you have to take care of these things. Okay? Now coming back to the important topic, beta, that is your mass change in chemical change. Okay? Now what is the main thing here? Now again one more activity. Beta, vinegar is what? Vinegar is, ma'am, acid, plus you add baking soda. Baking soda is what? Base. So we'll get some reactions, right? Now beta, after these things, this vinegar plus baking soda, when it is added together, it produces a gas called carbon dioxide. It is there in our atmosphere, right? So it produces a gas called carbon dioxide plus other mixtures, which at this point we don't need, right? Okay, I told you acid and base, but that's one of the important topics we will study in class 10th. Okay, so take care of that. Okay, now beta, when you add these two, you will get what? You will get an gas evolved out of this whole reaction, and that is carbon dioxide. Now we do two activities. On the first activity, what we did, we put what? Vinegar plus baking soda, right? And another also vinegar plus baking soda, but we did one thing. Now we took a balloon. We have all seen balloons, right? I don't have to explain that. Now when you add vinegar, when you add baking soda in the vinegar, so beta, baking soda is powder. Okay, it is powder, and vinegar is obviously your liquid. So you have liquid in one of the containers, and you add the powder of baking soda in it. Okay, you will see some gas comes out. First, what you will do, you will take a scale, a weighing scale. This is your weighing scale. Now what you will do, you will add a beaker, place a beaker, and then turn the those numbers to 0. You can do that. Okay, so now even the beaker is on the weighing scale, the scale shows 0, right? Now you add vinegar in that beaker. Done. Vinegar is, let's say, 100 gram. Vinegar is, let's say, 100 gram. Now you take one spoon and add the baking soda here, or just place some baking soda on this scale. Okay, the same amount of baking soda that you are going to add inside this solution. Now this scale read 100 gram plus, let's say, 10 gram of baking soda. So total 100 gram of weight is there. Okay, now you put this baking soda inside this container, baking soda plus vinegar, and you'll see some gas will come out. And the weighing that was first 100 gram, it will change to something like 105 grams or 107 grams. Okay, you'll see something like that. And you'll see what happened. But we studied that mass does not change. That is physical form. But here only mass does not change. Also, mass does not change in chemical change. Ma'am, what are you saying? But we clearly see that the mass change. Beta, mass changed. Why? Because of the gas that came out, because of the carbon dioxide that came out from this whole reaction. We didn't weigh carbon dioxide. The carbon dioxide that went to the air, it also has some mass, right? So then we do one more activity. We do the same thing we do. We weigh the baking soda, we weigh the vinegar separately before mixing them, and again it comes out to be 110 degrees. Done. Before their reaction. Then we do what? We take a balloon. Okay, this is a balloon, right? This is a balloon. I don't know the spellings of balloon. You take care of it. Okay, now we have some baking soda in this. And we'll do what? This is now a small cap of the beaker. So we invert this balloon onto in this beaker, and we fix this balloon on this beaker. Okay, so now it looks something like this. Now vinegar and baking soda again is there. Now they will again react. Again CO2 will be made, right? But this time the CO2 will not vaporize. It won't vaporize and go into the atmosphere. It will vaporize, but this balloon will trap all the CO2. It will trap all this CO2. Right? So now once the CO2 is trapped, you will see the rating of this weighing scale, it won't change. It will remain 110 gram only. Why it changed here? Because CO2 went inside in the air. Okay, in the air, but here we trapped the CO2 and it remained fixed onto that weighing scale. So this reading of the weighing scale, it does not changes. That means beta, mass in chemical change does not change at all after the reaction happens. And let's study what we have written. See, this is some kind of the structure that we are using, the activity. So we have a weighing scale, we have a beaker, we have a balloon. Okay, now beta, what is written? Read it carefully. So in one flask, set up one brisk effervescence. Brisk effervescence is called when CO2 is released. When CO2 is released, it's called brisk effervescence. Okay, gas escapes. Okay, so final reading is less, as we saw in the first case. In the second case, it's a closed setup. Closed setup means a balloon is there at the bottom, at the the face of the beaker. Okay, the whole of the beaker. So closed setup is balloon tied on flask, traps the CO2 and balloon inflates. One more thing, that when this CO2 comes out, okay, it comes out obviously due to the reaction, it inflates the balloon gets bigger. Okay, and that's how we see that something is happening, but the weight is not changing. So weight remains the same. With gas trapped, final reading is equal to the initial reading. Hence, the mass is conserved, which was our law of conservation of mass, that mass can neither be created nor be destroyed but can be changed from one form to another. So baking soda and vinegar mass is changed into carbon dioxide. Okay, the lost mass in setup 1 was just the escaped gas. The CO2 escaped, it was free, so it ran away. Okay, fun fact beta, fizzy drinks feel lighter after going flat for the same reason. So when you open your Coca-Cola can, although you should not drink it, okay, but you open the can and you will see lots of gas coming out. That's also carbon dioxide. So you get that sound, right? That's brisk effervescence. Okay, so when the carbon dioxide comes out and it goes, and if you place your hand there, you'll even notice the bubbles coming out. Okay, so those bubbles are coming out, that means gas is coming out, and after some time, and you drink that and you feel a little heavy, but you keep it there, let all the gas get evaporated, and you will see the drink is now light. It's just a sweet water, and it will feel like you are drinking some water and a sugar solution only. Then when the carbon dioxide has escaped, then the drink, the soft drink, will feel lighter. Okay, and that is why we say that mass change in a chemical change does not happen. Mass change does not happen in a chemical change. That's the basic idea of mass change in this particular topic and area of chemistry. Then those are the two topics. What are the two topics? Physical change. In physical change, mass does not change. Sugar plus water solution, salt plus water solution. But in chemical change, beta, mass does not also change. Okay, so mass also does not change. If it's changing, you see some escaped gases or something, and trap those gases with the help of balloon we did in this activity, and you'll see that mass actually remains the same again as well. Initial reading will be equal to the final reading. Then that's the main thing about mass change. Okay, let's do some question for this. Okay, a student burns 10 gram of ethanol. Okay, we have ethanol and 10 gram of it. Okay, and it is burning in an open beaker. See very carefully, the ethanol is burnt in an open beaker. After the reaction, no residue is left. Residue is better the left amount, right? See, this is a beaker. Okay, some things are left here. Residue is the left amount after something is evaporated. Let's say you have a salt solution, or you evaporated, you burn that whole solution. Water will get evaporated, salt will be there. So that salt will be a residue, the left out substance, the left out amount of substance. Okay, so residue is left. Is the law of conservation of mass violated? Also, 20 gram of hydrogen reacts completely with 160 gram of oxygen. How much water forms? Okay, so beta, they are saying when you burn ethanol, no residue is left. So in that beaker, no residue is left. Is the law of conservation violated or not? You tell me with the timestamp. Tell me in the comment section, is the mass violated or not? Ma'am, it is not violated, right? Because that whole thing is got converted into what? It's got converted into gas, right? So law of conservation of mass, beta, or you don't write it like that, LOCM, law of conservation of mass is not violated. It is not violated. Done? It is not violated because we read in the last slide that the gases will be evolved, the gases will escape, and that's why it feels lighter. There is no residue, but the whole ethanol is converted and escaped that beaker. Done? Okay, next beta, we have this water. They are saying that 20 gram of hydrogen, 20 gram of hydrogen, 20 gram of hydrogen, it reacts with 160 gram of oxygen. 160 gram of oxygen. How much water will be formed? Ma'am, just add these two. 20 gram plus 160 gram and 180 gram of water will be formed. 180 gram of water will be formed. That's your whole solution. Okay, beta? Okay, let's move to the next area of our chapter, that is law of conservation of mass. We already talked about it. Now, those were the two topics that you needed to study to actually understand clearly the law of conservation of mass. You saw? Mass was conserved, the gas was escaped, it might got converted into, from baking soda and vinegar, those are liquids and solid, it got converted into carbon dioxide, that is your gas. So the state of the matter is converted, the state of the matter is changed, but the total mass is not changed at all. Both sides it was 110 gram, 110 gram. Done. So matter can neither be created nor be destroyed in a chemical reaction. Done. Now it was proposed by what? Why do I do this? Antoine and your scientist, your very own, Antoine G. So Antoine Lavoisier in 1789, and he is called the father of modern chemistry. Okay, why can't he just have a name like Rakesh, Pulkit or Aditi, something like that, right? Maybe you can do it. Okay, so we won't have much difficulty to pronounce their name. I'm pronouncing it wrong, I know, but I can't pronounce it with the accent. Okay, so in every operation an equal quantity of matter exists both before and after the operation. Operation was what? Some chemical reaction, some physical change, some chemical change. Those are called the operation. So before the chemical reaction and after the chemical reaction, the mass of the matter remains same. Okay. Now beta, how do we verify that? How do scientists verify this? They verified that sodium sulfate plus barium chloride. Okay, they used sodium sulfate plus barium chloride and it got converted into barium sulfate, that got converted into white precipitate, and sodium chloride. This is a very important reaction in your 10th class. In your 10th class, don't worry. Ask any of your senior, they'll know this reaction by heart. So total mass before this reaction, beta, total mass of sodium sulfate plus barium chloride will be equal to the total mass of barium sulfate plus sodium chloride, because mass remains unchanged. And that's why we do balancing in chemical reactions as well. Okay, that's why we do balancing in chemical reactions as well. Okay, now Lavoisier used super precise balances. He designed himself an accurate to a fraction of milligram in 1700s. So beta, the weighing scales you do use, right? I have a weighing scale this small and it measures 0.1 gram, 0.2 gram. It just fascinated me and I bought it, and I used to measure random things on it. So what it does, he did it in 1700. Today it is not a big deal, but in 1700 it was a big deal, and he made it by himself. It was so accurate that he gave us a law based on that particular weighing machine. Imagine if that weighing machine was faulted, he would have never made a law telling that conservation of mass exists. Okay, great. Now beta, after that let's move on to a question, and the question on your screen is: students place 4 gram of calcium carbonate with 2.92 gram of hydrochloric acid. So we have 4 gram of calcium carbonate, CaCO3, and we have 2.92 gram of hydrochloric acid. How do I write calcium carbonate? You will learn it very soon. Don't worry about it. Okay, right now just look at this. Okay. In a closed container. Now this closed container is very important. Why? Because this tells us that even if some gas comes out, it won't escape, right? After the reaction, they measure 1.76 gram of CO2 and 0.72 grams of water plus okay, let's not write plus now, comma 4.44 gram of calcium chloride, CaCl2. Okay, these are the things they did. They take 2 reactants, CaCO3 plus HCl. They did a reaction and 3 products were formed, carbon dioxide, water and CaCl2, and their measurings are there. Okay, all the words I said, reaction, reactant, products, just forget about them. Just look at the numbers. Right now, look at the math here. Okay, now is the law of conservation of mass obeyed? So what you have to do, you just simply have to add these 2 masses and add these 3 masses and check if they are equal or not, right? So just add these 4 gram plus 2.92 grams. Add these very carefully. How much is this? 6.92 grams. Total mass of reactant is how much? 6.92 grams. Now, how will you add these? Ma'am, these are 1.76, 0.72, and we have 4.44. We have 4.44. How much this will be? 6, 4, 10. We have 2, 1 on the carry, 8, 7 and 7, 14 and 5. That is 19 and 1 upper 6.92 gram. And beta, these are same. So obviously the law of conservation of mass is obeyed. It is obeyed, right? And that's how you will do the questions. It is a solved NCERT question. So see the kind of questions they are asking. It's simple math. You just have to understand this language. Once you understand this language and write everything down, after that it's pretty simple. Okay? We have all the things here as well. So the law is beta, it is obeyed. Done? Okay, great. Let's move on to the next thing, that is law of constant proportions. Now in this chapter you will see that I take up one particular concept, I give you a question, I take up one particular concept, I give you a question, because that's how this chapter will work. This chapter is particularly small concepts, a little bit of just addition and subtraction, and you have to do the questions. That is the main thing. Okay, that's why I have so many questions for you in this whole particular lecture. Okay, now beta, moving on, we have law of constant proportions. What does that say? That in any compound, elements combine in a fixed ratio by mass, no matter the source. What does that mean by, ma'am? See, any compound, you have to understand what is a compound first. So H2O is a compound, your HCl is a compound, NaCl is a compound. So there are certain elements like sodium and chloride, they came together, form a compound called NaCl. We'll study about this in this particular lecture in a little time and dive down into a more chemistry section of it. But right now, combined is something which is combined and made up of lots of elements. Okay, so these elements, beta, they combine in a fixed ratio. By that, what do we mean? That beta, in H2O, that is your water. Now, if can I say hydrogen and oxygen combines and form water, but can I say HO is water or HO2 is water? No, I can't say that, right? H2O is the water. A water placed in a river is also H2O. In ocean is also H2O. In some lake is also H2O. In some very dirty sewer, it's also H2O. So, water that you find anywhere, it will be H2O. Hydrochloric acid you find in Germany or India, it will be HCl. H2SO4 you found in Australia or India or Spain, it will be H2SO4. So, these elements, they combined in a fixed ratio. This is ratio is what? 2:1. Can I write that hydrogen ratio to oxygen is simply 2:1? Right? So that is what they mean by law of constant proportions. So anywhere from any source you get the water, the ratio will always be 2:1. Right? Just give me a second. So this law was given by Joseph Proust, and it is also known as Proust's law as well. Okay, now the law of definite proportions, this is the most common name we will call it, okay, in the rest of the lecture, in the rest of the chemistry even. So make sure, what I'm trying to say is, you get HCl in Germany or India, does not matter, it will be H and Cl. Okay, so all the components in that compound, all the elements in that compound will be in the fixed proportion. In HCl, H is 1, Cl is 1. In H2O, H is 2, O is 1. In H2SO4, H is 2, S is 1, O is 4. Okay, so that's how these things are, no matter where you are in the whole world or even in space as well. Okay, no matter where you are in this whole universe. Done? Okay, so that's what is written. Water from a river, borewell, and ocean always has H and O by the ratio 1/8 is by mass. What we were talking about is by elements. Okay, so that's the one thing. Decompose 9 gram of pure water. Always 1 gram of hydrogen and 8 gram of oxygen will be there. Okay, now with an example, NaCl has, Na has 23 mass, Cl has 35.5. So the ratio will be 23:35.5. We are talking about masses here. Done? Here we are talking about the number of elements. Both is same. Done? Okay, now so 46 gram of sodium needs 71 gram of chlorine. Right? 46, that means 2 molecules of sodium will have 2 molecules of chlorine, but 2 molecules of chlorine will have 71 gram of mass, one molecule of chlorine will have 35.5 gram of mass. So that's how it works. Done? Understood? Okay, let's do again one more question. Ma'am, you are going to do so many questions today. Yes, and that's how you will understand. Okay, you are understanding, right? That's all. That's the thing that matters. A compound is 40% sulfur and 60% oxygen by mass. Okay, a sample contains 20 gram of sulfur. What mass of oxygen must it have? So that's the question. A little bit difficult, I will say, but what they're trying to say is just go through the maths of it. Whenever they give you percentage, so they're saying sulfur and oxygen by mass, they are 40% and 60%, right? So can I write this as 40:60? I can write it as 40:60, right? And if I take the fraction down, it will be 20:30. So that is the ratio of their masses are given. Now they're saying a sample contains 20 gram of sulfur and what mass of oxygen must it have? Now beta, if you see what you need to do, if you cut this down, this will be again 2:30. 3. So this is the ratio. Just what is the ratio? The ratio of masses. So the ratio is S by O. I can write ratio as division, right? That's the math. So S ratio O is given by 2:3. What is the mass of sulfur? Ma'am, 20 gram, right? Mass of oxygen we have to find, and it's equal to 2/3. So if I just solve it, O goes with 2. 2 into O equals to 3 into 20, right? This comes out to be, and if you solve it better, just do the calculation. 2 will come in the division, that will be cancelled by 2010. So 30 gram will be your answer. 30 gram will be your answer. 30 gram of oxygen will be present in this compound, which has 40% of sulfur and 60% of oxygen, right? B, CO has ratio, C ratio O is 3:4. How much oxygen combines with 9 gram of carbon? Again, the same thing you have to do. What they are saying, C ratio O. C ratio O beta was given by 3:4, and then we have 9 gram of carbon. 3:4, right? Converting them into masses, that is mass of carbon divided by mass of oxygen. Oxygen is in the ratio of 3:4. That's the thing they mean. Now mass of carbon is, we have to find, mass of carbon is given, that is 9 gram, and mass of oxygen we have to find, that is 3/4. Again the same calculation, 3 into mass of oxygen, and it will be equal to 9 into 4. 9 into 4, cross multiply, simply cross multiply, right? So this will be 9 into 4 divided by 3 equals to mass of oxygen, and this beta will come out to be 12 gram. This comes out to be 12 gram. Understood? Easy, very easy. Okay, next beta, moving on to the next thing, that is your Dalton's atomic theory. Ma'am, we studied in Journey Inside the Atom the atomic structure given by Dalton, right? But there is a proper theory given by Dalton, not just a statement. Okay, Dalton said that it is the tiniest particle, right? All matters are made up of tiny particles. Those are called atoms, right? That's the simple plain thing that Dalton told us. Now he also told us few more things, and we have to study those in this chapter. And beta, one very important thing is this postulates, these points are very important. Okay, so note down these points in your exam, in your notebook, and revise them again and again, recall them. Okay, and what are those points? Now atoms are indivisible. Dalton said that atoms are indivisible, and we agreed at that point that okay, they can't be created or destroyed in a chemical reaction, and that's true. To some point that is true. Okay, then beta, he said that atoms of a given element like carbon, like oxygen, like nitrogen are identical in mass and chemical properties. That means that all the atoms of carbon, it is in Germany, it is in India, it is in Australia, it is in USA, everywhere you will find a carbon, you will find its properties the same, its mass the exact same in every particular location. That makes sense, right? That makes sense. Then atoms of different elements have different mass and properties. Now mass of carbon and oxygen are different, so chemical properties will also be different. Nitrogen mass and chemical properties will also be different, right? But ma'am, these are common sense. Why are we studying these here? This is because beta, we are going to see their chemical properties, how they react with each other, how they combine with each other, how they combine with different elements. So that is why these common senses are important. Okay, then atoms combine in simple whole number ratios to form compounds. That means you cannot say 2.5 oxygen combines with 1.5 hydrogen. You cannot say that. Okay, it always combines with whole number. Whole numbers are what? 1, 2, 3, 4, 5, 6. So you can say 6 oxygen, 7 oxygen elements. You cannot say 1.5 oxygen. I saw 1.5 oxygen flying down here. You cannot say that. Okay, that is wrong. Done. The relative number and kinds of atoms are constant in a given compound. Again, the law of constant proportion. We are saying that in H2O, there will always be 2 elements of hydrogen and 1 element of oxygen. That is a compound, okay, and it will remain like that anywhere we find water. So the relative number, that this is 1, this is 2, and let's say this is H2SO4. So it will remain same everywhere. The relative number and kinds of atoms. The kinds of atoms are there. The kind of oxygen atom we have, it will be same everywhere in that given compound. Okay, so in reaction, atoms are just rearranging, explaining both laws at once. So they are just rearranging. When we talk about reactions, you'll study about reactions in class 10th. Okay, so you'll study acid plus base gives water plus salt. So you'll see what is happening. Is oxygen breaking down and going there? No, oxygen is breaking down. Oxygen is taking away. It's getting away from base and going and sitting with salt, making up some water and all, whatever. Okay, so they are just rearranging themselves. They are just rearranging themselves, hence telling us that mass is conserved. It got up from one place, sat in another, but the total mass of that thing remains same, right? And it said that these will have proper formulas and proper ratios in the nature as well. Okay, that's the whole theory about Dalton, that Dalton gave us, the Dalton atomic theory. That's the gist of it. Done. Now again, let's do a question. What's the question? Now, 2 gram of hydrogen combines with 16 gram of oxygen. We have 2 gram of hydrogen combines with 16 gram of oxygen. Let's write it down completely. Why am I not writing hydrogen as just simply H? You will see in a little bit of time. Okay. Now, then they gave to form 18 gram of water. Okay, they are forming 18 gram of water. Okay, so that's the reaction that is occurring. Reason is, according to Dalton's atomic theory, atoms combine in a simple whole number ratio by mass to form compounds. Okay, did Dalton say that? Did Dalton say that they combine in a simple whole number ratio by mass to form compounds? What do you think? What do you think should be the answer? Okay, have you answered? Right? Okay. Yes. So, ma'am, we just studied that Dalton said that atoms combine in whole number ratios, right? Whole number ratios. So, that is true. Done. So, assertion is true. 2 gram of hydrogen combines with 16 gram. So, 2 hydrogen plus 16 oxygen gave 18 gram of water. Law of conservation of mass. That is true. Right? And they are saying Dalton. So, both of these are true. But is the reason correct explanation for assertion? Ma'am, how this mass is linked to the conservation of mass? The whole numbers are linked to conservation of mass. That is not true. Okay, so your answer will be both A and R are true, but reason is not the correct explanation of A, of assertion, right? It's not the correct explanation of A. A shows that conservation of mass, of course. Dalton's whole number ratio is about number of atoms, not mass ratios. Okay, that's the one prominent thing about this is that in the reason they have given, according to Dalton's atomic theory, atoms combine as a simple whole ratio by mass to form compounds. But they do not combine with mass, they combine with simple whole numbers. Okay, so then that second will be not the correct answer. Okay, wait. Both true, R doesn't explain it. No. This will be wrong. Okay, I'll write down in the PDF as well. This will be a wrong option. Third option will be the correct. Assertion is true, but reason is false because they are saying whole number ratio by mass. I didn't even see mass. Don't do those silly mistakes. Done. So they combine in whole numbers, 2 hydrogens, 1 atoms. Mass can be different, right? Chlorine mass is 35.5. That can happen, but only 1 chlorine can be there. 1.5 chlorine can't come. Done. Understood? That's what this whole question meant. So assertion is true, but reason is false. Third is the correct answer. Third is the answer. Okay, not the second one. Okay, let's move to the next question. Next thing we have. Now beta, since we are talking so much about compounds and elements, that means somehow these atoms, Dalton said that atoms can't be broken. But he didn't say that they can't be joined. He didn't say that they can't be combined. So we as scientists in that time, they came up and they're like, okay, let me just join atoms. You said I can't break it, but I can combine it with some other atoms, right? So beta, they combined the atoms just like when cells are combined, they form a tissue. When tissues are combined, they form a organ system and all those things. Just like that beta, when atoms, the fundamental unit of everything around us, when atoms come together, they form molecules. When atoms come together, they form molecules. What are molecules? An electrically neutral entity of more than one atom. So when one or more than one atom, they joined and they are electrically neutral. They don't have charge. I am a combination of lots of atoms, right? Just like you are, just like everything is. But do I have a charge? I am neutral, right? I'm electrically neutral. That means this molecule, that molecule is made, it should be electrically neutral. It should not have a positive charge. It should not have a negative charge. Okay, that has a different name. But molecules, they are electrically neutral. Okay. Now, they are more than one atom capable of independent existence, showing all properties of that substance. So, H2O, water is neutral. HCl, even if it's acid, but it is neutral. Right? So, beta, when these compounds, these molecules are there with us, they are electrically neutral. Done? They are electrically neutral. However, H2O and HCl are not molecules. We won't call it as molecules. We will call them as compounds. We are talking about molecules. So, what actually are molecules? Now, beta, talking about it, see, atoms with 8 valence electrons or 2 for K shell, we studied about in the journey inside the atom, right? This is your nucleus. These are the electronic shells or stationary cells. Now, this is KLM. This can have only 2 electrons in this shell. This L shell, it can have 8 electrons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Then this M shell also can have 8 elements, 8 electrons, right? So that's how this works. Now, beta, if the atoms has 8 valence electrons are the electrons in the last shell, valence shell. Okay, so atoms with 8 valence electrons or 2 in the K shell are stable. So when I call electrically neutral, that I means stable atoms. Okay, they are made up of stable atoms. Stable atom means they have either 8 electrons in their valence shell or 2 in their valence shell if their valence shell is K shell. Understood? If their valence shell is K shell, then they can have 2 electrons in that shell and that will be stable, right? Like helium, which stays as a single atom. Now beta, you see helium, the atomic number of helium is what? 2, right? So this is the atom of helium. It has 2 electrons and this is the nucleus. Now this is stable. Why this is stable? Because this is the first shell. This is a K shell and these have 2 electrons. 2 electrons means valence shell is full. Valence shell beta, this one is full. Right? When this valence shell is full, that means this is stable. That means this is stable. Understood? Till here any doubt? Great. Next beta, we have sharing of electrons. Now what happens? We are saying that atoms, they come together, they combine to form molecules. That's the one thing we are learning, right? Now, how do they combine? See, they have electrons. When they come together, their electrons will also come together. So, beta, there are 2 types in which they combine. When they share each other's electrons, that means they share their electrons. The one element come, the other element come and they're like, oh, you need 1 electron. I also need 1 electron. So, let's share 1 electron each and we both will have 2 electrons. Okay? Done? Understood? Your brother has half a chocolate, you have half a chocolate, you combine that full chocolate, that's 1 chocolate. Now you both have 1 chocolate. Questionable, but okay, makes sense. For both of you, you have 1 complete chocolate. Okay, then beta transfer of electrons. However, this does not happen that your brother transfers his chocolate to you, but let's say he has a good day today. Okay, so he does what? He has 2 chocolates, you have 0. So I say, give me one please. So it's like, okay, I'll give you one. So he gives you one of his extra chocolates. Okay, and that's how you bond together. Okay, your bonding has increased, so transfer of chocolate happened, transfer of electron happened. That is your ionic bond. How will you say that? When transfer happens, when transfer of electrons happens, that is ionic bond. When sharing of electron happens, that is covalent bond. Sharing, covalent, transfer, ionic. Sharing, covalent, transfer, ionic. Okay, when atoms combine, their total energy drops. When they combine, beta, their total energy drops and the arrangement becomes more stable. So one thing you need to remember, that whenever we talk about energy and stability, it is inversely proportional, energy and stability. Now beta, everything in this whole universe, everything in this whole world just wants to be stable. You wants to be stable, your parents want to be stable, this pen wants to be stable. So when I leave it, it falls down, right? Because it is going towards more stability. Just like that, electrons, atoms, molecules, ions, cells, tissues, organs, everything wants to be stable. But stability is inversely proportional to energy. Stability is inversely proportional to energy. That means if you need more stability, you will have less energy. You will have less energy. And in here, when they come together, why 2 things will come together? To be more stable. Okay, why do atoms combine? To become more stable. Why do elements combine? To become more stable. And if stability happens, energy will decrease. Okay, energy will decrease and stability will increase. Then the force holding these atoms together is called a chemical bond. That's a very important thing. What is it called? When 2 elements come together, okay, they came together, but how they are staying there? Why are they not going away now? Why? Because they are combined together now with a bond. Just like 2 people marry, now they have a marriage certificate, they are combined with a bond, right? That's called marriage. So the marriage of 2 atoms is called chemical bond. The marriage of 2 atoms is called a chemical bond. We guys have emotional bonds, right? So just like that, atoms have a chemical bond that keeps them together. What's the fun fact? Bonding is just atoms being lazy. Why? They always settle into the lowest energy, most stable arrangement. Okay, so they are lazy, they don't want to go anywhere, they don't want to waste their energy, so they lower their energy. And if you lower their energy, their stability will increase. Okay, when you are laying down on your bed, your stability is maximum and your energy is the lowest, right? And that's what makes you a stable thing. You are just lazy, right? Okay. Now beta, talking more about of these bonds, these are our chemical bonds. We have 2 things to study. We have 2 things to study. We saw that atoms combine by sharing of electrons or transfer of electrons. Now we'll go a little bit deeper into that. Okay, first thing, when they combine by sharing, that is called covalent bond. What does that mean? Sharing is caring, covalent. Sharing is caring is covalent. Okay, C of caring, C of covalent. Done. That's how you will remember. Great. So this C, you will remember this covalent bond. Understood? That's silly trick. Now beta, what's exactly happening here is what you have to understand. Let's say you have hydrogen. What's the atomic number of hydrogen? Ma'am, if I don't know that, I should be very not good. I won't say anything. Okay, so atomic number of hydrogen is beta 1. Okay, it's 1, right? Now that means it has 1 electron. It has 1 electron in it, correct? Now how is that electron sitting? Ma'am, this is the nucleus. This is the nucleus, and then there is 1 electron in this hydrogen atom, Now, how much do I need for a stable atom? Ma'am, in K shell, we need 2 electrons. So, is it stable at this moment? Is this stable? No, ma'am, it is unstable. Why? Because I need 2 electrons to be stable in the K shell, but it only has 1 electron. What if I take one more hydrogen? What if I take one more hydrogen? There will be one more electron in with this hydrogen as well, right? In its K shell. Now, beta, this also want one more electron. This also want one more electron. Now, this is you and your brother, okay? And he's like, you give me your electron, I will give you your electron. We will share the electrons. And I'm like, good idea. Should we do that? What will happen? They both come close. They both come close and they share these 2 electrons now. They share these 2 electrons in between them. Now, this hydrogen also has 2 electrons and this hydrogen also has 2 electrons. Are they stable now? This needed 2 electrons in its valence shell. It has 2 electrons in its valence shell. This needs 2 electrons in its valence shell. It also has 2 electrons in its valence shell. So, this will become now stable. Earlier, when they were away from each other, they were unstable. They were unstable, right? But now that they are together, they became stable. They become more stable and hence the energy will be less. The energy will be less because what did we study? More stability, less energy. Done? That means how will you write it now in the language of bondings? Okay, how will you write it in the language of bondings? Beta, you will simply do, oops, okay, let it be here. Now, what will you do? H, it has 1 electron plus, or don't write plus, you have another hydrogen, okay? They will make a bond, they will make a bond and you will write that this is H2 now. What is, how it will be represented? H, single bond. What is it? It is a single bond. Single bond is made up of what? 2 electrons. 1 electron by this hydrogen, 1 electron by this hydrogen. So, it is being made by 2 electrons. 1 covalent bond is made by 2 electrons. Understood this whole story? Understood? This hydrogen has 1 electron, this hydrogen has 1 electron, this needs 1 more, this also needs 1 more. So they talk and they said, let's share each other's electrons. They share it. Now both of these have 2 electrons. This also has 2, this also has 2. Just that these 2 are shared between 2 hydrogens, right? Now, here they need 2 electrons in one valence shell, so they are unstable because they only have 1. Same with this, but now they have 2, so they are more stable. Now, more stability means less energy, right? How will you write this? You won't make these circles every time. You will write H2, that is H single bond H. One single bond is made up of 2 electrons. One single covalent bond. One single covalent bond. What is it? Covalent. Covalent means carrying, right? Carrying is sharing. So, by sharing of electrons, one single bond is made by sharing of 2 electrons. 2 electrons by 2 atoms. At this moment, remember this, by 2 atoms. Done? Understood? Great. Now, let's move back. What they are saying? Same thing. Ma'am, 1 electron of hydrogen, this 1 electron of hydrogen, they combine together, the final molecule looks like this. The diagram I made is actually the correct one if you want to show the chemistry behind it, right? But the final molecule, we just show it like H2, and there are 2 electrons in the shell now. Done? So, that's why I was telling you that beta, let's not write H here. Let's write H2 because let's see which one is more stable. Here, which one is more stable? Hydrogen is more stable or H2 is more stable? H2 is more stable, right? So, on this earth, everybody wants to be just a stable thing. right? They want to be just stable, right? So what will exist as a default molecule? Will the hydrogen exist alone where it is unstable, or it will exist with another hydrogen where it is stable? It will always exist with another hydrogen to increase its stability, and that's why beta, on this earth everywhere you will see that hydrogen always exists as two atoms. Hydrogen always exists as H2 molecule. Okay, until or unless we break it, we combine it, it is normally, when you take hydrogen gas, it is H2 in it, not just H in it. Okay, so hydrogen has one electron in K shell, needs one more. Two hydrogen shares the one electron each, and H2 with a single bond, H single bond H. This single bond is what? Due to sharing. Sharing is caring. Caring means C for caring, C for covalent bond. Okay, great. Let's talk about the next thing, that is your, okay, I did not, I think I did this with this chlorine atom as well. I think I sent the wrong PPT. Okay, let's do with the chlorine as well. One more example for you guys. Now beta, chlorine's atomic number is what? Ma'am, hydrogen, I gave you a chance. Chlorine, you have to remember. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Ma'am, chlorine is so hard. So just remember, chlorine, you have to remember the first 20 series. Beta, chlorine is 17. Okay? That means, what is the electronic configuration we learnt in the last lesson? 2, 8 and 7. So this 7 will be your valence electrons. Valence electrons. Why? Because they are in the valence shell. Understood? Understood? Okay. So we will just draw the valence shell for now, because beta, in bonding only valence shell takes part. That's again a very important thing to remember. In bonding only valence shell will take part. Okay, let me just draw all for now. Okay, and then I'll show you how to draw the correct one as well. Okay, we have 2 electrons in the K shell. 1, 2, 3, 4, 5, 6, 7, 8 in the L shell. Now in the last shell we have only 7. So 1, 2, 3, 4, 5, 6 and 7. Done. Let's make this again one more molecule. Now beta, look at this. Look at this. So we need this chlorine. This chlorine has 7 electrons. If it gets one more, will it become stable? It will become stable. If it gets one more, it will become 8. When it become 8, 8 is the stable number, right? So this chlorine just wants one more electron, right? So what will it do? It will go and approach another chlorine atom, and this chlorine atom will say, I also want one more electron. Let's share each one electron with each. So from this last shell, it shares one electron with this chlorine, it shares one electron with this chlorine, and the final molecule is become, that is the final, okay, the final molecule will become, and that will be beta your Cl2. That will be Cl2 molecule, and that will have a complete shell. By a complete shell I mean 2 electrons in the K shell, 8 electrons in their L shell, and 8 electrons now 4, 5, 6, 7, 8. 8 electrons in the valence shell as well. Here they just have 7 electrons. Here they have 8 electrons. And again, valence shell will take part. Okay, so the final will be like this. Now, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And 2 electrons are here. Now they are sharing one electron with each. Oh, I made one more. So, and one here, I will just make this. Yes. So, they have 8 electrons now. 8 electrons now. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So, both the chlorine atoms have 8 electrons and they are sitting together. So, they make Cl2. Understood? Great. Let's move on to the next thing, beta. That is your, now see, again this has single bond. 2 electrons are there, right? Single pair of electrons is there. So Cl2 will have a single covalent bond. 1 electron of this chlorine, 1 electron of this chlorine, they make a single bond. So they have one single covalent bond. One single covalent bond. Done. Now beta, this also has double bond. How? Ma'am, tell us. Okay, let's go to and talk about oxygen. Now beta, what's the atomic number of oxygen? 1, 2, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Oxygen is 8. So what is the atomic number? Atomic number of oxygen? Ma'am, oxygen's atomic number is 8. What is the electronic configuration? 2 and 6. Okay, let's draw the element of oxygen 1 and 2. This is oxygen. Okay. This is oxygen. Okay. Now talking about the electrons, K shell will have 2 electrons and the other shell, L shell, will have 6 electrons. 1, 2, 3, 4, 5 and 6. Okay, done. Now this O has 6 electrons. Now how much more electrons it needs to complete its octet? 8 electrons. Ma'am, to make 8 it needs 2 more electrons. It needs 2 more electrons. So it goes with to another oxygen. Hey bro, can we share 2 electrons each? Who is it? Why will I do that? Because you also need 2 electrons to be stable. Why we are doing it? To become more stable. Okay, so it approaches another oxygen and oxygen says, okay, for you I will do it. So what will they do? They will make a covalent bond. They will share each other's electrons and come together. So what will happen, beta? Look, this is oxygen, this is oxygen. This is their valence shell, this is their K shell, valence shell. No, wait. This will be overlapping. What do we call this? The thing, beta, where they are overlapping each other. We call it overlapping of shells. Okay, overlapping of valence shells we can also call it, or overlapping of shells we call it. Done. So beta, what happens now? 6 electrons each of them had. So 1, 2, 3, 4. These 2 electrons are here. 1, 2, 3, 4, and it says I will also give these 2 electrons. Now 4 electrons are being shared. 4 electrons are being shared, and this is K shell. So 2 electrons, 2 electrons, and this is your actually oxygen element. Okay, so 4 electrons are being shared. Oxygen, how will I write it? How will they teach you to write it in 11th, 12th class? Okay, they'll do 1, 2, 3, 4, 5, 6. Oxygen 1, 2, 3, 4, 5, 6. Ma'am, but it has 8 electrons. We are just writing valence shell electrons. These are 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. These are just valence electrons. Okay. Now each of them share 2 electrons. So what will you see? These 2 electrons will be shared. These 2 electrons will be shared. Which bond is this? One covalent bond includes 2 electrons. 2 covalent bond will include 4 electrons, right? So if 4 electrons are shared, we will call this double. We will call this double covalent bond. We will call this double covalent bond. Is it a little extra? Is it a little more? Just try to take it slow. Watch it again if you want. Okay, just try to take this slow. I'm teaching you very slowly. Okay, understand this whole thing. 2 oxygen elements, they want 2 electrons to complete its octet, because right now it has only 1 6, right? They want to take 2 more electrons. So it goes to another oxygen. Hey bro, let's share 2 electrons. I will give you 2 mine, you give me 2 mine. Total we have 4, and 4 plus 4 is what? It's 8. Right? So that's what it does. Now count the number of electrons of this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. That's what we wanted. 1, 2, 3, 4, 5, 6, 7, 8. That's what we wanted. Why did they do it? To become more stable. To become more stable. And that is why on this earth, everywhere when you talk about oxygen, you say O2. You say O2. And this is the chemical bonding of oxygen. What is that? Covalent bond. Why? C for covalent, C for caring. Caring is come by sharing. Sharing is caring, C for caring, C for covalent bond. And here they are sharing, right? So that means oxygen is combined with the help of double covalent bond. Understood? Great. Let's do one question on this, beta. Nitrogen has 5 valence electrons. Nitrogen has 5 valence electrons. Draw or describe the structure of N2 molecule. Okay. Now let's talk about nitrogen. Now nitrogen, beta, what is the atomic number? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Nitrogen is 7th, right? So atomic number of nitrogen is 7. What is the electronic configuration? Electronic configuration is 2 and 7 minus 2, 5. So the valence electrons are how much? 5. Let's make the diagram of or electronic shell of nitrogen. 2 electrons will be in the K shell and 5 will be in the valence shell. 1, 2, 3, 4 and 5. How many electrons does this need to complete its octet? To complete its octet, it needs 3 electrons. It needs 3 electrons, right? So it will now go to another nitrogen molecule and will say, bro, let's share 2 electrons. It's like, okay, sure. Carbon is, hydrogen is doing it, oxygen is doing it. I will also show you my loyalty. Right, so it becomes what? It becomes nitrogen and they share 3 electrons each. How would they do that? 1 and 2 in the K shell, undisturbed, unworried about the outer world. See, now this will share its 3 electrons. 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. Done? Done. So it shared its 3 electrons, it shared its 3 electrons. Now count the number of electrons with this nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. Octet is complete. 1, 2, 3, 4, 5, 6, 1, 2, 8. That is, octet is complete for both of the nitrogens and hence they are stable. They are stable. Now beta, look at this carefully. This is sharing 3 electrons. This is also sharing 3 electrons. And how many number of bonds are there? 3 bonds are there, ma'am. Now what we'll do? We'll give it a name. Triple bonding. Triple covalent bond. Triple covalent bond. However, this is not in your syllabus, this triple covalent bond. This is some of the science enthusiasts we have, okay, but just an extra knowledge. This question is, however, is in your NCERT, okay, so don't skip that. Right, so draw and describe the structure of N2 molecule. We described it. What happens? It shares 3 electrons with another nitrogen molecule. Sharing is caring, C for caring, covalent bond, triple covalent bond. Okay. Now also the atomic number of fluorine is 9. Explain the formation of fluorine. Now beta, fluorine is 9. Now let us make its that electronic structure 1 and 2. This is 2 electrons. Okay. What is the electronic configuration? 2 and 7. Right. So what are the number of electrons? What is the yes, so 2 electrons will be in the K shell and 7 will be in the L shell, right? Again, it needs 1 more electron to complete its octet. It needs 1 more electron to reach to 8. That means to complete its octet, right? So it again goes to another fluorine molecule. Ma'am, why are you telling this again and again? Practice, Meri Jaan, practice. You know how to practice for again and again and again, and that's how you will remember. You practiced it 5 times in this lecture only in under 1 hour. Do you think you will forget this ever? You will never, and that is why Aditi ma'am is here, so that you understand and learn every single thing in this particular video only. Okay, done. Now what do? They again combine with each other and share their one electron with each other. What do they do? 1, 2, 3, 4, 5, 6. The 7th electron fluorine shared. 1, 2, 3, 4, 5, 6. The 7th electron this fluorine shared. Now how many total number of electrons this fluorine have? 1, 2, 3, 4, 5, 6, 7, 8. Octet is complete. 1, 2, 3, 4, 5, 6, 7, 8. Octet is complete. And they are now stable. They are now stable. Done. Great. Okay, that's the whole thing about our covalent bonding as well. Now these are sharing single electrons, right? So they will make a single covalent bond. Done. F, single covalent bond. F, due to the sharing of one electron. Okay, let's talk about, oh, good. Great. Now HCl. Okay, yes, let's study about this. Now beta, what we studied till now? We studied about molecules. Okay, we studied about molecules, atoms, and we studied that what if 2 chlorine combine, what if 2 oxygen combine, how will 2 hydrogen combine, how will 2 fluorine combine, how will 2 nitrogen combine. But what if I tell you the combination is not limited to same number of elements? They are also valid to different elements as well. Can I combine H and Cl? Yes, you can. Can I combine calcium and Cl? Yes, you can. Can I combine H and sulfur? Yes, you can. And we will do that right now. And these are called compounds. The main 2 compounds we are going to study in our class 9th is HCl and H2O. Done. Let's see how to do that. Great. Now beta, talking about HCl, now see, hydrogen has 1 electron. We already studied it. Let me make it again. Now hydrogen's atomic number is 1. It is 1. To complete its duplet, that is K shell. To complete its K shell, it needs 1 more electron. It needs 1 more electron, right? Then beta chlorine. Chlorine, we also saw its atomic number is what? 17. To complete its octet, it needs, its electron configuration is what? 2, 8 and 7. To complete its octet, it needs 1 more electron. It needs 1 more electron, right? So hydrogen also needs 1 electron. Chlorine also needs 1 electron. Can I just make them share their electrons? Now they will say, no, I don't want to. I just want to stay with hydrogen. I just want to stay with chlorine. So H2 and Cl2 will be made. But we are like, no, you have to live together. You have to. This is a forced marriage. So H and Cl are forcibly married, and they say that hydrogen, what is its configuration? Why did I write hydrogen so sundar? Okay, hydrogen and its configuration is K shell. So it only has 1 electron in it. It only has 1 electron in it, right? I can see 1 electron. Then beta I have chlorine. Now chlorine will have 1 shell and 2 shell and 3 shell. Ma'am, it will combine with this. Yes, you just wait and watch. So there are 2 electrons of chlorine in the K shell, 2 electrons of chlorine in the K shell, 8 in the second shell, 1, 2, 3, 4, 5, 6, 7 and 8, right? And 7 in the last shell. 1, 2, 3, 4, 5, 6, 7, right? 7 electrons in the LM shell, okay, KLM. Now beta, this hydrogen goes to chlorine. Do you want to share 1 electron? And chlorine says, fine, I will share it. Okay, so they share with each other 1 electron. They will share with each other 1 electron, and hence beta, a covalent bond again. Why ma'am covalent bond? Because they are doing what? They are sharing, right? So for sharing, 1 covalent bond is there, and they're sharing 1 single electrons, right? So 1 single covalent bond will be there. So hydrogen and chlorine. So I'm just making the last shell of chlorine. Okay, that does not mean the other shells does not exist. If I'm not making the other shells, that does not mean all those shells does not exist. I'm just showing the valence shell, and that is what we are going to do moving forward. Okay, so one electron of hydrogen is shared here, one electron of chlorine is shared here. Okay, now how much electrons, what is the electronic configuration of the valence shell? 1 2 3 4 5 6 and this 7th one. Okay, so it shared the 7th one with hydrogen, and hydrogen shared its first one with the chlorine. Now count the number of electrons for hydrogen, 1 and 2. Duplet complete. Happy. 1 2 3 4 5 6 7 8. Octet of chlorine is complete. Chlorine is also happy. So they're like, okay, the compound is happy. So we make H, it shares 1 electron. Chlorine, it has 7 electrons. It has 7 electrons. It shares one of it, and that makes a covalent bond. And we have HCl. And they are made of what? Single covalent bond. Why? Because they share one electron each. Understood? And that is what is written. Hydrogen needs 1 electron, chlorine needs 1 electron. They share one pair, HCl is formed, a covalent compound. Now, this is not a molecule, it is a compound. So, HCl beta is now a covalent compound. Covalent compound because they shared each electron. Okay, they shared 1 electron each. Done? Great. Now let's talk about the next compound, that is our water, right? That is our water. Now again beta, water has what? H2O, that's we know, right? Now see, for hydrogen we have 1 electron, right? It needs 1 more electron, same like before, right? Now talking about oxygen, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, that's it, 8. Right? So oxygen has 8 electrons. The electronic configuration is what? It is 2 and 6. So it needs 2 more electrons. Ma'am, it needs 2 more electrons. But hydrogen only needs 1 electron, and hydrogen can give only 1 electron. Okay, that's fair. But what if I get 2 hydrogens? If I get 1 more hydrogen, it also has 1 electron. It also needs 1 more electron, but I need to incorporate oxygen as well. So 2 hydrogen will give 2 electrons. This need 2 electrons, and oxygen will also give 1 electron to this hydrogen, 1 electron to this hydrogen. Does that make sense? Yeah, ma'am. That definitely makes sense. Okay. So what will we do, beta? What will we do? Okay. Do not look at this. Look at this. So we have 1 molecule of hydrogen, 1 molecule of oxygen. I'm just making the valence shell now. Okay. And again 1 more molecule of hydrogen. Done. Now in the valence shell, it has 1 electron. It also has 1 electron. Don't make it here. It has 1 electron. It has 1 electron. Right. Oxygen has right now, it has 6 electrons. 1, 2, 3, 4, 5, 6. Done. Now this 1 electron it will share with hydrogen. This 1 electron it will share with this hydrogen, and it will make a covalent bond along with these hydrogen. What will be the covalent bond, beta? How will it look like? It will, ma'am, look like simply like this. So hydrogen, oxygen, overlapping with hydrogen, overlapping with another hydrogen. 2 electrons for hydrogen. Now look carefully. 1 electron of this hydrogen, 1 electron of this oxygen. 1 electron of this hydrogen, 1 electron of this oxygen. 1, 2, 3, 4. Now check the octet and duplet. Hydrogen has 2 electrons, duplet, happy. This hydrogen has 2 electrons, duplet, happy. This oxygen 1, 2, 3, 4, 5, 6, 7, 8 electrons, complete octet, happy. And we have our water molecule, that is H. 2 of hydrogens are there, 1 oxygen is there. So we have a single molecule of water, that is H2O. We have single molecule of water, that is H2O, with covalent, with 2 single covalent bonds. See, this is very carefully. Look at this very carefully. Here we had double bonds. Okay, here we have double bonds. 4 electrons were shared between 2 oxygens. Okay, 2 molecules, they were sharing 4 electrons among each other. Now, what is different here? Beta, oxygen is also sharing. The sharing of electron is 4. But it is happening between 3 molecules. These 2 are sharing 2 electrons. These 2 are sharing 2 electrons. So, these 2 are making a single covalent bond. These 2 are making a single covalent bond. So, we are making 2 single covalent bonds. We are making 2 single covalent bonds. Understood? We are making 2 covalent bonds. Both of them are single. Then oxygen needed 2 electrons, hydrogen needed 1 electron. So we took 2 hydrogen. We gave 1 electron to each hydrogen and each hydrogen gave oxygen 1 electron. Right? So that is your molecule formula of H2O, hydrogen. Done? Understood how they share electrons with each other? Done? Great. So beta, this is how you represent it. Hydrogen, single bond with oxygen, single bond with another hydrogen. This is how you express the water molecule. Do not look at this. Look at just what I taught you, this single slide. Okay, that will be enough for you guys. Done? You have understood it carefully. Now, let's move on to the question time. Question number 6. Show the formation of carbon dioxide. Okay, ma'am, we need to show the formation of carbon dioxide. How will we do that? So, ma'am, I have 1 single carbon and 2 oxygen. Let me write the atomic number. Carbon has hydrogen, helium, lithium, beryllium, boron, nitrogen. Oh, what did I say? Hydrogen, helium, lithium, beryllium, boron, carbon, oxygen, nitrogen. What am I doing? Did I just forget the series? How can I do that? Okay, Aditi, come back to senses. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Okay, so beta, carbon has what? It has 6 atomic number. So it has 6 electrons. So it will have electronic configuration of 2 and 4. Right? And we have oxygen. Oxygen is 8 atomic number. It has 8 electrons and its electronic configuration is what? 2, 6. Right? Now look carefully. We need 2 oxygen and 1 carbon. Why do we need that? Because beta, to complete its octet, it needs 4 more electrons. 4 more electrons. It needs 4 more electrons and it only needs 2 more electrons. It only needs 2 more electrons. So this needs 2 electrons. Oxygen only needs 2 electrons. So 2 of these electrons will be shared by carbon. But carbon needs 4 electrons. So we will take 2 oxygens. 2 electron will, this oxygen will give 2 electron. 1 more oxygen will give and carbon bond will be formed. Right? So there is something very different in this formula. Make sure to see this very carefully. Look. This is carbon and this is its valence shell. Understand? This is oxygen, its valence shell. This is oxygen, its valence shell. Understood? Now beta, look at this carefully. Look at this carefully. Now, carbon has how many valence electrons? 4 valence electrons. So 1, 2, 3, 4. Then oxygen has how many valence electrons? 6 valence electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now how many more carbon needs? Carbon needs 4. So it takes 2 of these and it takes 2 of these. 2 from this oxygen, 2 from this oxygen. Okay, let me make this one again. Yeah. You'll understand better. That's the only thing. So you have this carbon and the electrons are here. So 4 electrons in the last shell of carbon. So 2 these electrons make covalent bond. Double covalent bond. 4 of these electrons will make a double covalent bond. So what will be made? Ma'am, carbon, its valence shell, oxygen, its valence shell overlapping with carbon, oxygen, its valence shell overlapping with carbon. So we have 1, 2, 3, 4 electrons. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So and the rest of these are here. 1, 2, 3, 4. 1, 2, 3, 4. Now count their octets. Carbon needs how many? 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Carbon is happy and stable. Oxygen 1, 2, 3, 4, 5, 6, 7, 8. Happy and stable. 1, 2, 3, 4, 5, 6, 7, 8. Happy and stable. And this is the final formula of carbon. Now, how will you write this? Ma'am, 4 electrons are here. They are making, these two are making a bond, these two are making a bond, a double bond. These two are making a bond, these two are making a bond, a double bond. So, carbon making a double bond with one oxygen, making another double bond with one oxygen. So, this is the final formula structure of carbon dioxide, CO2, right? So, they will have 2 double covalent bonds. They will have 2 double covalent bonds. Understood? This whole relation, everybody clear? They have two double covalent bonds. Understood? Okay, what's the next that is given in the question? Hydrogen sulfide and ammonia. Okay, great. Hydrogen sulfide, that is H2S. Great. Now, what the first thing we'll do? We'll write their atomic configuration, atomic number. Hydrogen atomic number, ma'am, simply 1. And it needs one more electron. It needs one more electron, right? Then beta, again, that is sulfide. What is the atomic number of sulfur? Ma'am, the atomic number of sulfur is what? Let me know in the comment section fast. What is the hydrogen sulfide we have, right? So, what is the atomic number of sulfur? Do you know? Do you know? Okay, write it down. Great. Let's move on to the next. Oh, that one only. What was the atomic number? That is, beta, it's 16. Sulfur and carbon, they are in the same group. So, carbon has 6. So, sulfur will have 16. Carbon will have, what was the configuration? Yes, 16. Sulfur has 16. Okay. So, what is the electronic configuration? What is the electronic configuration? 2, 8 and 6. 2, 8 and 6. Not carbon and sulfur. I got confused. Oxygen and sulfur are in the same group. So, oxygen have 8 atomic number, right? So, what is the configuration? 2 and 6. Sulfur has a 16 atomic number. What is the configuration? 2, 8, 6. So, see, the last number is same. So, they are in the same column on the periodic table, same group of the periodic table. Just some extra information. Ignore if you don't understand. Fine. Just remember the atomic number of sulfur. That is 16. Right? What is the electronic configuration? 2, 8, 6. Understood? Now, beta, we have two hydrogens and one sulfur. Sulfur. So, I will just make the valence shell of sulfur. How many electrons are there in the valence shell of sulfur? Ma'am, there are 6 electrons. 1, 2, 3, 4, 5, 6. Okay. And hydrogen, it has only one valence electron. And another hydrogen again has one valence electrons. It only has one valence electrons. So, these two will make a bond. And now sulfur will have what? Sulfur needs how many? Sulfur needs 2 more, right? So, it gets one from this hydrogen, one from this hydrogen. And hence, everyone is happy and stable. Everyone is happy and stable. How, ma'am? How they are happy and stable? I will show you. Okay, so they are now, sulfur is here, hydrogen is overlapping with sulfur, another hydrogen is overlapping with silver, right? Sulfur. So, they have how many electrons? 1, 2, 3, 4. 1 it gave to this hydrogen, 1 it gave to this hydrogen, 1 this hydrogen gave to the silver, 1 this hydrogen gave to the silver. Count 1 and 2. Hydrogen is happy and stable, duplet is complete. Hydrogen is 1 and 2, happy and stable, duplet is complete. Sulfur 1, 2, 3, 4, 5, 6, 7, 8, happy and stable. Right? Now, 2 electrons are shared. H1, sulfur, 1, 2, 3, 4, 5, 6. So, only one electron from each side is shared. So, they will make 2 single covalent bonds. They will make 2 single covalent bonds. Done? Understood how we go through it? So now you have a homework of doing what? Of doing ammonia, NH3. Write down the atomic number of nitrogen, their electronic configuration, and then 3 hydrogens we have. So let me know in the comment section what is the final formula. How many covalent bonds, single, double, triple, ammonia is making with 9H3. Okay? Okay, great. Let's move on to the next topic, beta. That is your naming of covalent compounds. Beta, naming of these covalent compounds is super important. It will help you in your +1, +2 as well. Okay, so make sure you understand these things very carefully. The first thing you need to understand is this. Anywhere you have 1, that means 1 hydrogen, 1, let me not name any element, but you will see. So wherever 1 element is there, we will write mono. Wherever 2 elements are there, we will write di, 3 tri, 4 tetra, 5 penta, and 6 hexa. And these goes on 7 hepta, 8 octa, 9 9 is nano, 10 is deca, 11 is undeca, dudeca, 12 is, okay. So it goes on, but for now you have 6. Okay, just remember till 6. Now beta, what are they saying? First element keep its name. Okay, whenever the first element is there, let's understand with a very important example, that is CO2. So do I write monocarbon because carbon is 1? No, I don't, right? I simply say carbon. Carbon dioxide. We know all this name. We know this name. Let's understand with the help of already known example. So this is carbon dioxide. Okay. So they are saying that with the first element, mono is dropped. With the first element, the first element keep its name, mono is usually dropped. So with here, do I write monocarbon dioxide? No, I don't. I simply write carbon because carbon is the first element. So mono will not be there in the carbon. Okay. Second element ends in ide. That means see here. Second element. Now CO2. Second is oxygen, right? It is oxygen. So instead of writing oxygen, we write oxide. We write oxide because it gets the name ide. Second element gets 2 as well and the name ide. Then suffix ide. Suffix is something that we write at the end. Right? So it will get second element ends with ide. Understand? Carbon, we don't write mono with it even though it's single element, but we simply start the first name carbon and the second name ends with ide. It ends with ide, dioxide. Right? Now the third thing is drop the last vowel O and A. Whatever the last vowel is, O and A, that is dropped. Prefixes before a vowel. Again, done. Don't worry about it. So monoxide, pentoxide, but keep I, dioxide, trioxide. What do we mean by that? See beta, here now 2 elements of oxygen are there. So we wrote what? Di, right? We write dioxide, right? We write dioxide. But if I want this one, what they are telling you, that you have CO2 and you have one more, that is CO, right? Now what will be this name? From the first one we don't write mono, we will simply write carbon. Okay, second one only one oxygen is there, so I will write mono. So I will write mono, right? Now should I write, this is oxygen, right? And the second one will get ide, right? So do I write monooxide? Is this the name? Monooxide? No, that's what they're saying. They're saying drop the last vowel, that is O and A. So this last vowel will be dropped. It will not be monooxide. This won't be it. It will be monoxide. It will be monoxide. Simply monoxide. But if di is there, I is there, so keep that I. Here we won't drop this I or this O. It won't be doxide. Right? It won't be dioxide. These are not true. Okay? If I is there, write down I with oxide. But if O is there, then drop one of the O's. Okay, understood? Let's look at some examples. Don't worry. So single carbon, single oxygen, but the first name will not get mono. So we write simple carbon. Second one is single. So we write monoxide, monoxide, not monooxide. Right? True? That's what I said. Carbon, 2 oxygens. So again, carbon remains carbon, not monocarbon. Carbon remains carbon. We have di, 2 for di, dioxide. Right? Not monocarbon dioxide. Right? Then CS2. Again, the first thing remains the same, carbon. 2 of the sulfurs, 2 sulfurs. So di for 2, sulfide, ide is what we write in the last name, ide. So carbon disulfide is the name. PCl3, phosphorus, no monophosphorus, phosphorus. 3 for tri, right? 3 for tri. So trichloride, because end one it gets ide. So phosphorus trichloride, carbon disulfide, carbon dioxide, carbon monooxide. Understood? Now it goes into the brain, right? Now, but when hydrogen is first, no prefix on it, that means H2S, again no prefix, right? Hydrogen remains hydrogen and this becomes sulfide. That means we are not saying dihydrogen sulfide. No prefix on this, even if hydrogen is 3, even if hydrogen is 2, 4, 5,000, just write hydrogen, no prefix in it. Okay, here we don't have any prefix before because all of them is single, right? Carbon is not C2, carbon is not C2 here, it's simple carbon here, but hydrogen is H2 here. Even then, what is this? Even then we are not writing, give it some time. Okay, even then we are not writing dihydrogen oxide, right? Because when hydrogen comes, we don't write any suffix. Di won't come. It will simply be hydrogen sulfide. Done? Hydrogen sulfide. And here also for the second, with hydrogen, we are not using hydrogen monosulfide. Are we using hydrogen monosulfide? What is happening? Are we using hydrogen monosulfide? No. With hydrogen, we are simply using their names, hydrogen sulfide, right? Not dihydrogen sulfide. Done? Understood? The naming is clear. You will feel a little bit difficult in the starting. Don't worry about it. Just try to learn it carefully. Okay? Try to learn it carefully. Don't jump into it and don't think that, oh, this is hard. Just practice it 4 or 5 times. Understand these. Just read this again and again. Read this again and again and you will be good. Okay. Let's try to do some heavier ones. What are these? Sulfur 6. 6 is hexa. Hexafluoride. Hexafluoride. Ide ends with, second word ends with ide. Sulfur hexafluoride. What is this? N2O4. Dinitrogen. So in the starting, if 2 is there, we are using di. But single, we won't use mono, we won't use. But di, we use. Dinitrogen tetraoxide. Dinitrogen tetraoxide here. Okay. So, because they said drop the O and A. Now we have tetraoxide. We won't write tetraoxide, we write tetroxide. Okay. Dinitrogen tetroxide. Dinitrogen tetroxide. Understood? All the laws, all the names, clear, right? Very clear. Good. Now, beta, moving on to next type of bond. This is where we end our covalent bond, right? The next type of bond is your ionic bond. Now, we wrote what? Sharing of electron is covalent bond, but transfer of electron is your ionic bonds, right? So, sodium has 281 configuration. Right? Now, sodium has 281 configuration. Let's see this. Sodium has a configuration of 281, right? Chlorine has what? Chlorine has 17, right? So, it has 287. So, can you see if it loses 1 electrons, because gaining 7 electrons requires lots of energy. It cannot gain 7 electrons. But losing 1 electron is easy. And it just needs 1 more electron. Losing 7 electrons is a big task, but gaining 1 can be done. Okay, so sodium does what? Sodium and chlorine does a deal. Okay, it's like I will give you one electron and you will take one electron. You need one electron, I will give you one. Sodium is like, I am a Danveer, right? Danveer like Karna. So he's like, okay, I will give you one electron and your octet will be complete. But chlorine does not know that his octet is also getting completed. He is also getting stable by giving this extra electron, right? So sodium, its valence shell, again I'm drawing the valence shell. So it has one electron. Then we have beta chlorine. It has one. How many electrons in the valence shell? 1, 2, 3, 4, 5, 6, 7. Now, if I even try to make a share covalent bond, will it make? It just needs one electron. It needs 7 electrons. So no covalent bond can be formed. Sharing can't be done, right? We can't share 7 electrons with this. So it just give its one electron to chlorine and it will become a ionic bond. So NaCl, it gets one electron, 1, 2, 3, 4, 5, 6, 7, 8, and its valence shell is empty now. So it has empty this one. Now this was its valence shell, but if it goes, this become its valence shell and this is complete, its octet, right? So it is complete. Chlorine on the other hand, 2, 8, 7, it gets one more electron. Now here we have 8 electrons. So again its octet is complete and this is beta ionic bond by transfer of electrons. Sodium atom has one electron, it gives one electrons to chlorine and we have ionic bond. Now you have studied one thing, that whenever someone loses electrons, it gets a positive charge. Whenever someone gains electron, it gets a negative charge. It lost one electron, it gains one electron, so a single positive and negative charge. And when they combine beta, an ionic bond is formed, NaCl. Ionic bond means bond between ions. What are the ions here? Na plus is ion, Cl negative is an ion. It won't be an element now. It has plus charge, it has negative charge. So these are ions. Anything that has more electron or less electron, with the lost electron or they gained some electron, they become ions, right? And that's the important part. Na plus, Cl negative, NaCl is being formed. Done? Okay, let's do one question. What kind of ion will oxygen form? Fill in the blanks. Magnesium and okay. We have to see what kind of ion oxygen form. First, what will do? Ma'am, atomic number of oxygen is what? It's simply 8. And what's the electronic configuration? 2 into 6. So will it lose 6 electrons or will it gain 2 electrons? It will gain 2 electrons. So this will simply be, it will gain 2 electrons. So 2 negative will be the ion of oxygen. Understand? Now magnesium gives 2 electrons to become Mg plus 2. Okay, we have Mg plus 2 and beta we have chlorine takes 1 electron to become of course it takes 1 electron, so it becomes chlorine negative, right? Now dash ion of magnesium and dash ions of chlorine gives MgCl2. Okay, great. Now let's understand this. Mg plus 2, chlorine takes 1 electron only, so it is 1 electron. Now beta, magnesium is given 2 electron, chlorine is just taking 1 electron, so magnesium will give 1 electron to this chlorine. It still has 1 electron to give, so it will give another electron to another chlorine. So 2 chlorines will take 2 of these electrons. So what will this become? Mg plus 2, MgCl2. That means 1 ion of magnesium will give 2 electrons to 2 ions of chlorine. Understood? Clear? Great. So that's the whole thing. That means now 1 ion of magnesium will and 2 ions of chlorine will make MgCl2, that is your magnesium chloride. Done? Understood? Great. Now moving on beta, these are some of the elements that you need to remember. Their valences. Valences means how many electrons they are losing or gaining. We studied about this in the last chapter, right? How many electrons they are losing, how many electrons they are gaining is their valency. The sodium has 7 electrons in their valence shell. So it has 1 electron in its valence shell. So it will lose 1 electron. So 1 is its valency. Similarly, potassium also has 1 electron in its valence shell. It will lose it. So 1 is its valency. Calcium and magnesium 2, 2. Aluminium and iron 3, 3. Copper has 2 electrons. Zinc has 2. It loses 2. Ma'am, how will I remember this? Mostly you just have to remember 1 to 20 elements. You remember their atomic number, their electronic configuration, and you will know how many they need to complete its octet. That will be its valency in negative. How many they have to lose to complete its octet or duplet. That will be its valency, but in positive. Right? It needs 1 electron, so chlorine negative needs 2 electrons, O2 negative, 2 electrons needed, negative, OH negative, NO3 negative, CO3 2 negative, SO4 2 negative, NH4 positive. These are some of the things you have to remember for now, because beta these are some higher classes work. Okay, done? These are some of the things, just remember for now. But one important rule is that cation named first and ion named second. That is simple. That means beta, the positive ones are called cations. The positive ones are called cations and the negative ones beta are called anions. And all of these cations and ions are called ions. So positive ones are cations, negative ones are anions. Okay, so we write cations first, then anions. NaCl, KO2, and we'll see that calcium oxide, right? So we write cation first, anion in the second place. Now, simple anions end in ide. So we see simple anions, chloride, oxide, sulfide, hydroxide, they end with ide. But polyatomic ions, that means more than one, N and O, more than one. C and O, more than one. S and O, more than one. Actually, hydroxide is also more than one, but some exceptions are always there in the chemistry, right? So these does not end with ide. These ends with 8, or usually they have their own name, right? Done? Understood? Okay, let's see the next thing we have, writing the chemical formula based on those valences. Let us try to write 2. I will write 2 is your homework. Okay, HCl is your homework. Okay, H2S. Now beta, H, atomic number of H is 1. So it will gain 1 electron or lose 1 electron. Mostly it loses 1 electrons. So H2 is always positive. Okay, sulfur beta, it gains electrons. How many electrons it will gain? Its atomic number is what? Its atomic number is 16. Right? That means 2, 8, 6. It needs 2 electrons. It will not lose 6 electrons. It will need 2 electrons. So 2 electrons are needed. So here 1 electron is lost. 1 electron is lost. 2 electrons are gained. So 2 of these hydrogen will give 2 of these electrons to sulfur. That means H2. But how will you write this? You write with the help of valency. Ma'am, H is always plus. So sulfur needs 2 electrons. That means S is 2 negative, right? So you just cross multiply these numbers that are in their heads. Cross multiply and write it down in the feet. So you will get H2S. Okay, try it with this one. Al 3 positive, O 2 negative. So cross multiply, write it down their feet. We have Al 2O3. Understood? How will you know this? By remembering these valences. Okay? How do you remember these valences? By remembering the atomic numbers. You know how to write the electronic configuration. You know what if they gain or lose the electrons, and hence you will know the formula. It's very easy. You just have to give a little practice. CaCl2. Calcium will be 2 positive. Cl negative. Just multiply. It will be CaCl2. Understood? Okay. Next beta we have just this thing. Exactly what I told you here. Exactly what I told you here is the thing written here. You will get all the PDF in the description. Now beta, we have some of these elements as well. CO3 2 negative, SO4 2 negative. How will you write these? These will be written in such a manner. Let's say Ca has +2, right? CO3 2 negative also has +2. So where will this +2 go? Will I write CaCO3 2? Will I write CaCO and this will get multiplied with 3 into 2, 6? No. You will write simply one thing. This Ca will get this 2, Ca will get this particular 2, and this whole CO3 will get this 2. So this will be this. So you will get CaCO3 twice. You call it CaCO3 twice, right? Similarly with all other things. Done? Great. We have one question for you. Name CO2. Okay, you just have to name them. Okay, fast. Name it in your head and fast. If you want to comment, very welcome. Carbon dioxide. Okay. Nitrogen dioxide. Sulfur hexafluoride. Phosphorus tetrachloride. Whatever we studied in the last slide. Exactly that. Okay. Write formula for sodium hydrogen carbonate. We have sodium. We have hydrogen. Carbonate is what? CO3. Carbonate is CO3. So NaHCO3 is the formula. Ferric chloride. We have ferric chloride. FeCl3. How we write? Beta ferrous is what? Fe plus 3. Right? Chlorine is Cl negative. Write down in that fit FeCl3. Right? Similarly, if you want to see here as well, this will be Na positive, H positive, CO3 2 negative. So this goes with these 2 negatives will balance out with plus of this and plus of this. So you simply write NaHCO3. Okay, that is the formula of sodium hydrogen carbonate, FeCl3, and we have compounds of Fe plus 3 with OH negative. Oh, Fe plus 3 with OH negative. Ma'am, we just studied. Just multiply this 3 with whole OH. So Fe, there is simply one, OH bracket 3, FeOH thrice. K plus CO3 2 negative. K plus CO3 2 negative. Simply K2 CO3. This was even simple, right? Understand how to write these. It's getting simpler, right? It's getting simpler. So that's the whole method why we do this. Done? Okay. Next beta, we have a very important different ionic versus covalent compounds. It is very, very, very important. So make sure you learn all these points, right? Solubility in water, but ionic solutions are there. They have shared their electrons. So they are generally soluble in water. In water also we have H positive, O2 negative ions, right? So they become ionic inside the water solution. Okay. So soluble in water, generally soluble. In these are not soluble. These are camphor, naphthalene. Covalent bonds, they are sharing. Sharing is caring. They are caring for each other. They will not break. They will not be soluble. Then solubility in kerosene. Then they break. Then ionics are insoluble, but covalent are, they dissolve readily. Okay. Conductivity, ions, they don't conduct. Ions are fixed in their lattice. But covalent, they don't have any ions. They are sharing the electrons. They are transferring the electrons. They have ions, but they are fixed inside their whole structure. Lattice is called the structure. Okay. They don't have any ions. Then conductivity in water. So yes, they are free to move. This is in solid. Okay. Conductivity in solid. So they are fixed. They don't move. In liquid, they break into ions. So they are conductors. But they are not. Right. Sugar is a covalent bond. So it does not have electricity in it. Right. Melting and boiling points. They have high melting and boiling points because they have shared they have transferred the electrons now. But they have low melting and boiling points because those covalent bonds, their sharing can be broken by boiling, by melting. Okay. Now molten ionic compounds also conduct electricity. Heat frees the ions from their lattice prison. So they are saying that ionic compounds, they conduct electricity while heating. Molten, these can be melted, right? So there, when we heat them, the ions get free. Here they are trapped inside the structure. They are fixed inside the structure, right? But when you heat the solid, it starts to melt, right? Why it starts to melt? Because these ions, they get freed up. So they can easily move, right? So they can easily move and hence the lattice can be broken. Great. Now beta, we have one more question of the day. No. We have this. Now beta, see, we have molecular mass and formula unit mass, a very important topic. Question will come from this topic definitely. So what is this? Ma'am, when we have H2O, for this you have to learn some of the masses as well. Mostly these will be given in the questions. Okay, you don't have to worry. But what is the molecular mass? Ma'am, H2O is a molecule. What is the total mass of H2O? I know the mass of hydrogen, I know the mass of oxygen, but what is the total mass? So I will add the mass of hydrogen, add the mass of oxygen, I will get the total mass. There is a catch. So beta, the molecular, for this you need to know molecular formula. They will give you, they will tell you that tell us the mass of water. The mass of hydrogen is this, mass of oxygen is this. So what you will do, you will add those. That's not the case. What you will have to do, mass of hydrogen is given as what? Mass of hydrogen is simply 1. But there are 2 molecules. So you will have to multiply this with 2. Plus, mass of oxygen is what? It's 16, right? Yes, it's 16. So simply add 16, only 1. So this will be 18 grams of total mass, not grams, 18 U. No, there is a separate unit for mass of molecules, right? That is U. You'll learn about that, don't worry. Okay. Then beta, CO2. So mass of carbon is what? It's simply 12. Okay, so mass of carbon is 12 plus mass of oxygen is to what? 16. Should I add these two? No. 2 molecules of oxygen is there. So I'll multiply this 16 with 2, right? And I will get what? 12 plus 32 and I will get 44 U. Okay, that's the total mass of carbon dioxide. So ionic compounds form 3D crystals, not molecules. We use formula units instead. So beta, these are what? These are covalent bonds. These are covalent bonds. Ionic compounds, these are covalent compounds, right? Covalent bonds, covalent compounds. Ionic compounds on the other hand, they give electrons, they take electrons. So they form 3D crystals, not just molecules. They don't form molecules, they form crystals. You will learn about that, don't worry. Again, they will form crystals, and so we calculate formula unit mass and not their molecular mass. What is that? Simply almost the same sum of atomic masses in one formula unit. That is simplest ion ratio. Okay, same, nothing different, just Na2O. So sodium has 23 into 2 plus 16, again 62 unit, right? Same. Now this you will be a little different. How will you do? See, 40 we have written plus this whole NO3. Mass of nitrogen is what? 14 plus mass of oxygen is what? 16. 3 oxygens are there into 3 plus all of this has come twice. So we'll multiply this with 2 as well and do the calculation. Okay, so that's the main important thing, difference about covalent bond and ionic bond, but there is not much difference in the mathematics of it. Done? Fun fact, the unit U is so tiny that 18U of water is 1 molecule. 18U of water is of 1 water molecule. 1 water molecule. How much water do we drink? We don't even realize. A single drop holds about, just look at the zeros. Look at the zeros. How many? A single drop of water has these many molecules of water. And each of these molecules of water has 18U of molecular mass. So that's interesting. That's interesting, right? Okay. Let's see a question on this particular thing, and that will be beta what? Here. Find the molecular mass of nitric acid HNO3. So now they have given you the mass. Okay, don't worry, they'll probably give you, but they'll tell you what are the important, I will tell you what are the important molecules whose mass you should remember just for the safety. Okay, now what will I see? Mass of hydrogen plus mass of nitrogen plus mass of oxygen, but into 3 because there are 3 oxygens. Mass of hydrogen is 1 plus mass of nitrogen is what? 14 plus mass of oxygen is what? 16 into 3. So this will be 48 plus 14 plus 1, right? So this will be what? 363 U, right? Don't forget to write U. That's important. Done. Then we have molecular mass of CH4. We have molecular mass of CH4. Mass of carbon is what? 12 plus hydrogen is what? Into 4. So 12 plus 4 is what? 16U again. Done. Formula unit mass of KCl. What will be that? KCl. So mass of K plus mass of chlorine 35.5. This you should remember, mass of chlorine plus 39 of potassium. It is good if you remember the masses of 1 to 20 elements, at least atomic number of 1 to 20 elements, mass number of 1 to 20 elements. That will be a good thing to do. Okay, so just add these t. What will be this? This will be 74.5U. Done. And what else is there? Formula unit mass of MgOH twice. Okay, good. Let's do this. MgOH twice. What is the formula of mass of Mg? Mass of Mg is 24, right? Plus. Now, you should also remember the mass of oxygen, that is 16, plus mass of hydrogen is 1. The whole has 2. So multiply the whole thing with 2, whole mass with 2. So 24 plus 17 into 2. 17 into 2 is what? 34 plus 24. So that will be 58U. Done. Basic math. This is just the addition of mathematics. And beta, that is all for this. And we have, what did we study? We studied the law of conservation of mass. Mass is neither created nor destroyed in a reaction. Law of definite proportions, very important. A compound always has the same elements in a fixed mass ratio. Atoms bond to become stable. Covalent means sharing. Ionic means transfer of electrons. Covalent formula show atoms per molecule. Okay. Ionic formula show the simplest ion ratio. Then molecular mass is covalent, formula unit mass is ionic, add up to the atomic masses. Tiny atoms combine to build the entire universe we live in. Then, and that is your whole chapter. The chapter was what? Atomic foundations of matter. Done. And that is it beta for this particular video. There will be a link in the description for the PDF. Join the session, join the channel, and we are coming live every day at 5 PM. So join that, ask your doubts, and I'll meet you in the next batch, in the next session. Tata, bye bye.